Poor use of JSON data in LLM prompts means inflated costs and less accurate results. In this video, we'll be discussing how to better structure this JSON data for great, cost-efficient prompts. The ubiquity of JavaScript in the JSON format means that it's a common use case to take JSON data from our applications, services, or scripts and use it in our large language model prompts. We'll showcase the more effective JSON-based prompting using Vertex AI Generative AI Studio. A critical part of our strategy involves leveraging a project called Jsonnet, which allows for templating and advanced transformations of JSON data. This will help us clean up and enrich our JSON data before we send it to our prompts. At the time of this recording, the Generative AI Studio is powered by Google's Palm 2 AI. Let's jump into the Google Cloud Console to set this up. We'll move to the Vertex AI service and the text prompt section to view the window where we'll experiment with our JSON data. We'll look at the before and after when transforming our JSON data and sending it to this large language model. We'll use the Cloud Shell IDE for our Jsonnet transformations. Let's place our raw data in an input JSON file to start. Oftentimes, data coming from our applications and services might have shortened keys. For instance, the social media section here with Twitter and LinkedIn links. Unfortunately, this is not very natural language friendly and therefore LLM friendly. We may encounter other issues such as unintuitive abbreviations or unclear data nesting and structure. As an example of the latter case, maybe key value pairs are structured oddly, with the key names dictating the data connection rather than something more intuitive like a JSON dictionary. In any case, we're often forcing the large language model to do a lot. We're making it try to understand unusual abbreviations, terminology, structure, and data connections. But there are ways we can clean this up so that we can get a better, more natural language-friendly input to our model. To give us a baseline, let's put this input in a question in Vertex AI. For instance, let's say we want to write a hypothetical author biography based on the following blog post metadata and include at least 2 article examples. Much of the response is extrapolated from the actual data. There's not much data here, so the model is doing its best, but the result could be improved. As a specific example, we received titles that were derived from the body of the text. However, these subtitles were not provided in the data. We can improve our approach by enhancing the data that we're passing into this prompt. Let's do this using transformations based on the Jsonnet system. Let's say our blog post is going to be imported from this input.json file, and then we'll create a new structure that we'd like to see for the output. If you don't already have the Jsonnet library, you will need to install it using commands such as apt-get update and apt-get install Jsonnet. Let's go ahead and run the transform file as an early test. As you see, our output file is empty, as expected. Why don't we start breathing some life into it with some JSON fields? For instance, our post title probably deserves some spotlight here. You know what we can probably leave out? The unnecessary clutter from our data, say the numeric ID for the post. This can potentially confuse our LLMs. Plus, we actually save money by bidding adieu to this extra baggage in our prompts, since these LLMs are typically character or token based pricing. How about we introduce the author of our story, including things like the biography and social media handles? We're intentionally sticking to spaces and non capitalized words in our JSON keys to keep things simple for our AI model. After all, we want it to mirror the elegance of a natural language structure rather than the more convoluted territory of snake case, Pascal case, or camel case. Time for a quick midway check, yeah? Let's test our efforts so far by running our transformation once more. All good. The next step is to structure these property key value pairs neatly in our new output JSON file. The brackets allow us to have calculated field names. Even though we could use looping structures here, let's keep it simple and hardcode our four properties. And voila, it's working like a charm. Let's bring in our content and tags without any changes. All right, let's test out our new output JSON file. The improvements look promising. Notably, it's actually correctly capturing the two article titles without hallucinating subtitles anymore. Overall, less guesswork and more grounding. Time for a reality check with another prompt, comparing the before and after again. Let's try, what is the contact information for the author? Interestingly, both the raw input and spruced up output gave us the same solution. So we can infer that simple, direct questions may be served well both ways. Nonetheless, a little grooming of the data surely won't hurt, right? And finally, the big reveal about costs. Our input JSON character count stands at approximately 1,500, meaning it would cost around 8 hundredths of a penny per LLM call according to Vertex AI pricing. Now, what if I were to tell you that our output JSON has just about half the characters? Meaning your cost would shrink by nearly 50%. Let's say we scaled the system up with 10 million prompts per month. The cost difference would be about 4,200 versus 7,800. Visualizing this, we can show the direct path from JSON to Generative AI Studio at 7,800, while the alternative path with Jsonnet transformation only runs us 4,200. We hope this video has been helpful, and we'll keep an eye on the comments section for any questions. Thank you for watching, and please enjoy responsibly.